Hello, I'm Dr. Papia Bhattacharjee. In this problem, we are given this equation and we have to find dy dx. But you have to find it implicitly. So note that this is, as we call, an implicit equation, and we have to do implicit differentiation to compute dy dx. Before I start this problem, since we have exponential function right here, let me quickly remind you of how we take the derivative d dx of the function of the form, say, e to the power u. Now notice that we are differentiating with respect to x, but we have a different function here. We have a u, and u is usually a function of x. So how do we take the derivative of that function? This is, you take the derivative of the exponential function, and that is itself e to the u, and then you have to multiply with the derivative of this function in the exponent, du dx. Okay, let's keep that in mind. And let's come back to our equation. So we have to calculate dy dx. So the first thing you should do is apply d dx both sides of the equation. So apply d dx. So what do I mean by that? Is take d dx of the left side of the equation and that is equal to the d dx of the right side, which is 0. Okay. So for the left-hand side, see there are 3 expressions. They're all added together. So let's separate it into the derivative of each one added together. So we will have d dx of x e to the y minus d dx of 10x plus d dx of 3y. And that is equal to, now the right hand side, let's compute this derivative right away. See, it's the derivative of 0, and 0 is constant, and you know that derivative of constant is just 0. So now let's figure out the derivative of each of these expressions separately. So let's start with the first one. Notice that this is x times e to the y. That's the function. And therefore, it's a product of 2 different functions. So let's say this x is the function v and e to the y is the function w. And you have to take the derivative of a product of 2 functions, so we have to use product rule. All right, so let me remind you how to use product rule. So when you have 2 functions v and w, you keep one of the function as it is and then take the derivative of the second. Then add, keep the second function as it is and take the derivative of the first one. So that is the product rule. Okay? So that is the derivative of just the first function, the first expression. Now let's continue. d dx of 10x. Okay, so that is 10 times d dx of x is just 1. And then the last expression, we have 3 times y. So 3 is constant. You write it down. And notice this is the derivative with respect to x, but we have a different function here. Y is a function of x. So 3 times this is d dx of y. So it is dy dx. All right. Now let's simplify this first 2 terms. So we have x times, now here we have to compute the derivative of an exponential function and go back and recall how do we calculate derivative of e to the u. So here this y is like u. This is like our u. And notice what the derivative is. It is e to the u So e to the y, and then times we have du dx. But u is y, so this is just dy dx. Okay. The second term, e to the y stays as it is, and ddx of x is just 1 using the power rule. And then we have negative 10 and plus 3 dy dx. And I forgot to mention this should be equal to 0 because this is an equation. And here also this should be equal to 0. Okay, so we have an equation and we have to solve for dy dx. So how do we do that? We combine the terms that has dy dx and keep it on one side, and the terms that don't have dy dx, we move it to the right hand side. So notice that there are two terms here where we have dy dx. So combine them together. So we have x e to the y dy dx plus 3 dy dx. Those two, keep it on the left, and then to the right side of the equation, move the other two terms because there is no dy dx. So one term that is plus 10, you move it to the right, and then e to the y has a plus sign, so when you move it, you get negative e to the y. In the next step, what we do is we take out the common factor dy dx from these two terms. So take it out, and we will be left with, from the first term we have x e to the y, and from the second we have plus 3. So this part and this plus 3. And that is equal to 10 minus e to the y. So how do we extract dy dx from all of it? See, we just have to divide both sides of the equation by this expression that is attached to dy dx. So let's do that. So we get dy dx is equal to, we are dividing this entire thing, so that is equal to 10 minus e to the y divided by x e to the y plus 3. And so we have our expression for dy dx from this initial equation. Thank you.